Welcome to the new saga. We've moved out of switching and into routing. And appropriately so. If you're moving through this series in order, which I really encourage you to do because it'd be kind of weird. It's like watching a movie out of order. We just finished up with VLANs, and we kind of have these hosts that are now in separate worlds. They're in separate networks. But we never really answered the question, well, what if that host wants to get out of its world? What if it wants to get off of its VLAN? That's where routing comes into play, and this is where it all begins. So in this nugget, we're going to look at what I would call routing core, as in what is routing. Let's define it. Let's get it on paper where we go, okay, this is the definition, we get it. Then we'll look at the Cisco routers themselves, as in let's look at the hardware. What do they look like? What do they feel like? What kind of interfaces do they have? Can I change those? All those kind of questions. And then finally, I'm going to cram in here the basic router configuration, and I put review on there because it's the same thing as the switch, it's just now on the router because both devices use a common IOS. Let's start off by bringing it back to the big picture. What is routing? Now, up till now in the series, we've been focused on this, which is the switching environment, creating VLANs, doing the base config, managing the switch, speed and duplex, all those kind of things. It's all sitting there within the LAN. Now, that, essentially all of this, let me draw the square, shoop, 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 shoop. All of this represents one network. As soon as you hit the router, you've created a divide in the network. So let's define the network. The network is a logical thing, as in it's based on the IP protocol. So when I define my subnet, my IP address range, I might say something like, let's go, this side is 192.168.1.0/24. That's like half of the homes in the world use that subnet because that's what all the widgets you buy, like D-Link, Netgear, that's what they do by default. So what that means is everybody that's connected to that switch, assuming, now this is assuming, because I know we just got done with VLANs, there's no VLANs, so this is all VLAN 1 essentially on that switch. This guy is .50, this guy is .51, whatever IP addresses from that network you'd want. Now, this guy would likely be .1. Doesn't have to be, but most commonly is either the first or the last IP address from the subnet, because this guy will use, or I should say both of these guys will use that as their default gateway, 192.168.1.1. So they're ready to get off their subnet. They want to come over here. Now again, new router interface. This is a new network. So this is network 1. This is network 2. And actually, in reality, this is network 3. And that's the job of a router, is to start moving that data between the networks. So maybe on the right-hand side, this is 192.168.2.0/24. Again, first 3 octets represent the network, so everybody realizes that's a new network. That's the host .50 on there, and that's the .1. That's 192.168.2.1 on there. Now, what will happen is this guy will grab his, let's say we grab a command prompt on him, and we type in the command ping 192.168.2.50. What happens? Well, he's going to look and he goes, okay, wait a second. I am part of the 192.168.1 network. That's not good. That's not on my network. I shouldn't say that's not good. He's just like, that device is not on my network. So I realized that I'm not going to be able to send an ARP message and reach him. Because that's how it normally talks. It sends out an ARP, a broadcast to everybody saying, hello, who is this? But he realized, oh, that's not going to work. Because he is on a completely different subnet than me. That means I have to go through my router. So instead of sending an ARP for 192.168.2.50, which he knows will not make it, he sends an ARP for 192.168.1.1. Now, why is he doing that? Because that has been pre-configured. You, as an admin or a DHCP pool, has pre-configured that as his default gateway. So broadcast message goes out saying, hello, I need the MAC address for 192.168.1.1. This guy comes back and responds and says, oh, that's me. He goes, great, I want to use you to reach this guy over here. So what he's going to do is assemble a packet. So his message is a ping, right? He's pinging the other side. Source IP address is going to be himself, 192.168.1.50. Destination IP address will be this guy over here. That's where he's finally going, 192.168.2.50. right? That's where he wants to go. Now, source MAC address, now we're talking on the local network. So I have to cross the local network to get to this. So source MAC address will be him, whatever it is. Let's just say it's 1111. That'll be his source. The destination MAC address will be whatever the router is. So we'll say he's 2222. That'll be the destination. So essentially, from a switch perspective, which only looks at layer 2 information, the switch just sees, okay, you are 1111 going to 2222. So it takes him from here to here. Now the router gets that and he goes, oh, okay, you're trying to reach me. I see that based on the MAC address. Great, so I'll process you. But I'm noticing that you're not trying to really get to me. You're trying to go through me, not to me. You're going to 192.168.2.50. Now we come to a concept which will be big for us as we expand routing. He looks at his routing table. And he's going to say, do I know how to get to 192.168.2 network? Do I know how to get there? If he doesn't, that's the end of our story. It's rather short. The router's like, I don't know how to get there. Drop, drop, drop. He starts dropping those packets. But hopefully someone... That's you. You would have gotten involved at some point and told him, hey, to get to the 192.168.2 network, you need to go to this guy. Now, enter network 3. We'll just say, let's just make it for grins something way different. We'll say network 3 is 10.1.1.0/24. Maybe he's .1, he's .2. So in my routing table, I would have put some kind of entry. I would have educated my router to know to get to this 192.168.2 network, he needs to go to 10.1.1.2 as a destination IP address. So this guy would then say, okay, well, I'm going to send it to you. Now remember, there's a whole MAC address story that we've left behind in the switching world. He's actually going to take the original source and destination MAC and get rid of it, right? Because that's only valid right here. Now he's on a new network, so he's going to fill in the source MAC address from this interface and the destination MAC address of this interface, right there. So he'll have new ones. Gets it to this guy. Once again, this guy gets it. He's like, ooh, a message for me. Because he's looking at the MAC address, and he's like, oh, wait a sec. No, it's not for me. It's for 192.168.2.50. And he looks at his routing table, and he pulls it up, and he goes, well, wait a sec, 192.168.2.50. Wait a sec, I'm plugged into that network. That's connected right out fast Ethernet 0/0. We'll say, I'm just saying. And so he goes, well, great. Then I'm going to, again, strip off the source and destination MAC address a second time and replace it with the source and destination MAC address to allow this communication. Now, obviously, I haven't drawn it in there, but that line represents a switch. That's connecting. These guys don't just have lines that connect them. So they're going through the switch, and poof, we have communication. We have one side talking to another and hopefully back. Now remember, this guy has to have in his routing table that we started up here, he needs to know how to get back to 192.168.1.0. He needs to know how to get here in order for full communication to happen. And I know it's easy, well, isn't he smart enough to say, well, if it came from that direction, I must have to go back that direction. Nope, he's not. You have to go in and educate this router, either manually, I'm going to give you some previews of where we're going. That's called static routing, where I manually go in and tell it where to go, or we allow them to kind of figure it out themselves using a routing protocol. That's called dynamic routing. And the routers will build their routing tables kind of by themselves, but there's a lot of thought that has to go into that. So this is what routing is. It's the process of moving packets between them and yet isolating them. So all the broadcasts on this network stay there. All the broadcasts here, there won't be many of them, but they stay there. All the broadcasts here, that we've separated the networks, and we can even put security boundaries in there. We can put on things like access control lists to say, well, this guy can get across, but this guy can't. So we put these dividing lines between these networks and really say, okay, this router has the authority and control of that entire network. He is the manager of that network. So all of this routing is facilitated by a Cisco router. And the last thing I've mentioned, they are iOS powered, which we now know the iOS. It's what we've been working in all along, this operating system. But they are Ceph enhanced. What does that mean? Well, I put that statement in there, iOS powered, to convey the fact that routers run on software. The iOS is the brain behind the router. They don't really have that much hardware to help them out. Now, I'm kind of enunciating my words, because when we talk about switches, there is that magical, you remember this? ASIC world. Application specific integrated circuitry. That's the hardware inside that's making those things move and move fast. So packets are coming in at wire speed. That switch can it's going like lightning. Now you hit the router. The router does not have the same ASICs that a switch does, because it supports all the features. While the switches are lightning fast, they can't do all the kind of stuff that a router can. They can't do stuff like NAT, network address translation. They're very limited on, for instance, the kinds of quality of service or access lists that they can support, if they can even do it at all. You have to have a really expensive and bigger switch to do those kind of features. But when you come to a router, you get all the features. You can do routing protocols. You can do NAT. You can do fill in the blank. They can do all of the key routing functions that we need, but they do it via the iOS, meaning they do it via software processing. Now, software, anytime you talk about software processing, it's always slower than hardware. Always. That's why we, those of you gamers out there, that's why you go buy those big old $500 video cards, right? That make your video games go much faster, is because you've offloaded a lot of your video processing to the hardware rather than your processor and your software trying to do it itself. Same concept here. We've offloaded, or I should say, the iOS is that software-based process. It's slower. So Cisco said we got to enhance that. So they came out with this method called Ceph, where they moved as much into the hardware, as much into kind of cached processing. Ceph stands for Cisco Express Forwarding. It's a way that a router runs, and we'll talk a little bit more about Ceph later, to try and optimize this routing table so that it doesn't bog down the whole network. But frankly, a router will never, well, I shouldn't say never, a router is not as fast as a switch because it doesn't have those same ASICs. And just like with the switch, before we dive deep into the configuration of routers, I want to get you physically familiar with them to where you can look at them, identify them, understand what they're connecting to, kind of like we saw how all the cablings run through the wall, you hit the patch panel and all that, right? So what I'm looking at here is the Cisco 2800 series. It's not the latest series of Cisco routers, but it's the only one that I could find a really good picture of online, to where they show a little stack of them. Cisco has all kinds of different routers series that are available, each one having different capacity, different sizes. So I mean, as you go up in model numbers, you go up in price, but what you gain is increased capacity, like it can handle more traffic going through it. Also increased capacity in terms of modules. Like for instance, this guy right here, I love that router. I have one. That was my lab router from years ago. Where it's a 1U. That means if you look in a rack, you've got 1 unit of space that is consumed. Usually typical racks, well, they range on the maximum, but around 42U is a maximum size of rack. So they don't eat up that much space. And then they have 4 modules. Now, I know it's tiny, but this is a picture of a 2801 without any modules installed. So you can see over here, I mean, this is the close-up view. You see like the fast Ethernet, the console port, all that kind of stuff. And then there's 4 blank plates to where you can install your modules. Now, just to give you an idea in terms of price, when you look at a Cisco router, you'll look at the price and you're like, oh, yeah, it's kind of costly, but it's not too bad. Oh, just wait. Just wait until you price out the modules. Now, the one I just circled right there is a very old module, but a lot of these routers, I mean, you will likely eclipse the price of the router by purchasing the modules for the router. That's where I think a lot of the functionality comes in. So, typical routers, I will say most Cisco router will have 2, sometimes more, but most of the time 2 Ethernet interfaces, meaning they have, right here you can see this is fast or gig Ethernet depending on the model of router you have, and usually they will be identified as fast Ethernet 0/0 and then fast Ethernet 0/1. Now I'm giving you generalities. Every router is different, and that, I mean, just getting used to it. I mean, some of these routers, if you were to flip these guys around, they don't all have these little slots. Some of them, like if you took one of those guys and flipped around, will have these big modules. Like, this is like a 2U router, so double the size of this, and it just has these big open slots to where you can put in a card that hosts these modules. So you could have, let me show you. Not that my art is lacking by any means, but if you look at this, like here, let me grab that. It looks like a good picture. So you can see this. This is a big. See these things right here. These are kind of WIC modules. That's what they're called, WAN interface cards or VIC voice interface cards, where you can put small little modules inside. That's what I'm showing you right here. These are all those small little modules right there. But on these bigger routers, you can get essentially these big modules that, for instance, you can see this one module has two built-in, looks like, I can't see, but like fast Ethernet or gigabit Ethernet ports. And then right here are two modules that you can slide in on top of that. Maybe that give you serial ports and all of that. So depending on the model of router you get, I mean, you really can deck these things out and expand them and grow them with all kinds of different cards. And the cards are where your functionality is. The cards are, your connections. Sometimes they'll have a card that's like a, for instance, they have a Unity Express module. It's called CUE, Cisco Unity Express. That's a voicemail module for a phone system, to where it literally, on a card that slides in a router, they have a full-blown voicemail system or a security system. I mean, you get all kinds, like the cards are where the functionality is at. So that's where those fit. So now these routers will typically have two built-in Ethernet interfaces, not always, but most of the time. So that alone, just with no modules at all, allow them to connect to one network. Here's a switch up here, plugging into fast Ethernet 0/0, and then they can have another one connected to another switch up here, or maybe a Cox or Quest or something brings in an internet connection that you plug into fast Ethernet 0/1, and that can connect you to the cloud or the internet, I should say, and then you kind of route between your internal network and the rest of the cloud. Now, some of these are, for instance, like T1 interfaces. They're getting fewer and fewer and fewer as new connection types are out there. But I would say for a long time, these kinds of interfaces will be out there. They are technically serial interfaces. This was the original old school. Let me show you how WAN connections look, right? I mean, logically, this is what we're doing. We draw them like this. We're like, okay, well, office in Arizona is connected, and we have this magic lightning bolt, right, that connects over here to office in Colorado. And we're like, yeah, and that magic lightning bolt happens. Well, what's with the magic lightning bolt? I mean, tell me what's behind that, Jeremy. Well, if you were to really dig into it, you have service providers that are out there. Here's the United States, right? So I'm just grabbing the United States. That's a horrific. Over here is California. I'm giving you some bearings, right? Here's me in Arizona. And you have service providers that their job is to go around the country digging. They've got shovels, and that's what they do. They dig and they put in cable, and they put in cable, and they put in cable. They put in cable. They put in satellite dishes. They put in, things that allow you to reach things overseas. They put in. That's their job. Now, I don't want to have to. If I buy an office in California and I'm in Arizona, I don't want to have to get my shovel out and start digging holes in the ground and running cable from my office to California. That's just not efficient. I'm going to pay somebody else to use their cable. Welcome to the idea of a service provider. So a service provider, let's say here's my Arizona office. That line represents drywall, right? Outside of my office is this nice little patchy grass lawn and little tree and all that kind of stuff. I say, okay, I just got an office in California. I call up service provider X and I say, hey, I'd like to buy a T1 line from you. I'd like to, I guess technically, I'd like to lease. That'd be more accurate. A T1 line from you. I'd like to lease to use your cable that you've pulled out your shovel and you've dug to California, or you've dug maybe halfway to California and then partnered with another service provider who dug the rest of the way. I mean, there's all kinds of partnerships, and this guy connects to that guy and they pay and blah 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 blah, right? So service provider X comes in and is like, sure thing. They say that'll be what's a T1 cost? Maybe $250 a month to get that connection going. And I say, okay, that sounds good. So this is their truck. They pull up, they start walking across, they dig a little trench into your premises, and they put a wall jack right there, and they say, okay, that wall jack represents our demarc. Now, I know that for some of you are like, I know that word. Some of you maybe not. Demarcation point, what is that? That's where the point of responsibility passes. If something on that side of the demarc breaks, you pay for it. If something on Actually, I should be real world. If something on this side of the line breaks, they convince you that it's on that side, and you pay for it. But technically, you're supposed to, or they're supposed to pay for everything on that side of the line, right? But that's besides the point. That's technically not how it works. So in the wall, we then take this line. Now let's talk about the old days. In the old days, we would take this line and plug it into this special device called a CSU DSU. And it was just, think of it like a line converter. Because every vendor used to have their own kind of interface that they would use. There's actually, I think, 5 different types of serial connections. And this would convert the line coming in from the service provider, which looks like a normal Ethernet cable, into a serial port that plugs in there. And it does other things. It's not just a converter. It does like diagnostics on the line, making sure the line's okay, measuring drops in traffic. Yeah, it does some stuff. It's just a fancy modem is really all it is. And that's how we did in the old days. Now CSU DSUs are all but gone from most places. And now these, you'll actually, if you look really close, a lot of them say integrated CSU DSU because technology has evolved. We no longer need this big old box on the outside to convert it. We can just run this line directly into our router, and now we have a serial. So this one might be like you notice. I don't. You can't see that. I can't see that. It says. I think it says slot 2, slot 1. Maybe not. So maybe this is. It's hard to see. Slot. It's a slot number. So let's just pretend that says slot 1. So we plug it into, we'll say that line right there, and that's now going to be serial 1, that's module 1/0. So that's that port. So we can give that an IP address, and if we actually were to, fast forward over here in California, there's their drywall, there's their wall jack, and they've got, a router that's plugged in there. So physically, that's kind of how it looks, to where, that router will then connect and, go across that cable, and now we can talk to Arizona. Does that make sense? It's kind of the, so obviously you don't want to draw trees and grass and small insects and things like that. So people just say that's the lightning bolt. So when you see a lightning bolt between two routers, if we were to kind of like expand that's what the lightning bolt really is. Okay, well, what I want to wrap up with is the base configuration of a Cisco router. Now, first thing I want to do is orient you to what kind of router this is. I've got a 2621 XM router, which what a great lab router that is. Let me show you a picture so you can see what we're configuring. This is a picture from eBay, but because this is a very common, it's very old, let's say 2621 XM, probably 2002, 2003, but still very good. I mean, usually when you talk about technology that old, it's like, well, that can't be worth anything. Well, actually it is. It's a really good router. There's still a lot of them in production today, but most people will use these as lab routers. So you can see built in right here, I've got 2 Ethernet ports. That's fast Ethernet 0/0, 0/1. There's my console port, the blue one. The aux port is the black one. That's if I want to plug in a modem. Switches don't have those, by the way. Then up here I have 2 little modules to where I've got slot 1. Slot 2, those are for the little WIC modules, WAN interface cards. And then I've got a big module where I can put all kinds of functionality. You can get one of these. That's an ether switch module where you can kind of turn it into a swouter to where we've got, you can actually run a whole office. Like if it's a small office, you're like, hey, we've got 10 people at this office. Then you can just buy one of these little modules for the router, and now you've got 10 people that are able to plug in and use kind of an all-in-one device. Those things are pricey though, I've found. Compared to buying just a normal switch. So power supply. I mean, it's just a basic router. So that's what we're going to start with. And you might look at this slide and go, well, this looks familiar. It is. It's almost exactly the same slide as the switch because the base configuration between the two is the same. So some of this will be new. Some of it will be review. So let's take a look. So I just plugged into the console port of this router. No config on here. First thing, I'm going to start off with actually a verification command. Something I do often. Well, first off, let's do a show IP interface brief and get that on the table so we can see, okay, this router, I'm looking down at it right now. It's got a couple of, as you saw from the image, fast Ethernet 0 and 0/1, and then I've got 2 serial ports in them. One is actually the new style that we saw on the last page. Actually, we saw both styles. Excuse me. We saw the new style that with the integrated CSU DSU, and then there was an old style one. I've got one of each sitting in there. That's serial 0/0 and 0/1. But notice, first off, something very different from a switch. All of them on a router are shut down by default. That's the norm. A switch, it works out of the box. A router will not work at all out of the box. You have to configure it to get it running because the Cisco doesn't know what you want to do with this thing. So the second verification command, and this is what I was going to show you, show version, tells me what I'm working on. I look and I go, okay, I've got a Cisco 2600 series software. I see the version of software that this is running, how long it's been running for. Hit the space key, and then right down here, that's where I can see the exact model number, as well as kind of a quick summary of what interfaces are inside of there. Now, I didn't tell you this, but I also do have voice interfaces, not part of this series at all, but I actually use these as voice over IP routers with something called FXS, Foreign Exchange Station interfaces in there as well. I can see how much flash, 32 megabytes of flash, and this is just, you can kind of piece this together. That's 128 megabytes or so. You add those two numbers up. 128 megabytes of memory. For a router, that's decent. I mean, that's not, I know you're thinking like Windows 7 needs 5 gigs or Windows 8 or whatever. It needs insane amount of memory. Well, routers don't, they don't run Microsoft Office. They just route packets. So I'm kind of orienting. I feel good now. Okay, let's go in and start the configuration. So first off, host name. I'm going to type in host name. We'll just call this CBT router, just like we had CBT switch. Immediately the host name changes. Console password, telnet password, enable password. Let's just fly through those. Line console 0, password Cisco, and let's require some logins on there, or login. Let's do a exec timeout of 0 space 0 so I don't get kicked off if I'm idle. Logging synchronous. And I'm so glad the tab key works because I would probably fumble through the spelling of synchronous. And then let's go under the VTY ports. That's our telnet ports. Now look at that. Insanity. This guy supports 181 simultaneous sessions at a time. Well, good grief. I don't expect 181 administrators to all be on my router at once. Would you? Good. So what I would do is I would just say, well, let's just configure the number that I would expect, maybe just 0 through 4. I wouldn't even expect 5 people to be on this router at the same time, but hey, let's just do it because that was the norm before. So I'm going to type in password Cisco, and Cisco, and you remember, let's do a show run, and let's do begin with line. And by the way, you will feel a lot slower on a router. It takes a little longer for it to execute some of these commands. So you can see that I've got VTY 0 space 4. Login, you remember, was the default. I don't have to type in login under here, whereas I did under the console port, because logins are always required, or should always be required for telnet sessions. So I get out of there, and now we want to do our enable secret, right? Enable secret. Cisco, protect our privilege mode. Now we jump over to the right-hand side with the IP address, and we start getting into some of the default. Now first off, I changed this from the switch. It used to say management IP address. Now I just have IP address. This is where you've got to get into your planning side of things. Like, what is this router? What is this device do? What does it connect to? So if I connect, maybe I'm using this for a home network. I'm kind of, and I would encourage you to do this. Replace your little Netgear device that you use at home or whatever you use with a real Cisco router. There's no better way to start learning than actually make it real and make it consequential. Like, if I can't figure this out, my internet connection at my house doesn't work. My spouse will be mad. So you can add a little pressure to yourself to get this thing going, and so there's a lot to be gained by that. So let's say we're configuring it for our home. So maybe we want this fast Ethernet 0/0 to be 192.168.1.1 with a Class C subnet mask, right? Maybe that's what we want. Maybe it's corporate network. Maybe we've got internet connections, all that kind of stuff. So in this nugget, I'm not going to dive deep into all the possibilities. That's going to be what the rest of the series is about. But for now, let's just give it one IP address. So I'm going to let's do a show IP interface brief. See the interfaces, and let's just say that I plugged, click fast Ethernet 0/0 into my home network. This would plug into the switch. So I would go into interface fast Ethernet 0/0, and throw that in there. IP address 192.168. Now I've assigned it an IP address, but it's still shut down, so I need to do a no shutdown. and power that back up. Now, as of right now, it's a base configuration, so it's not actually plugged into anything. So what it's going to tell me is it's going to say, hey, I'm up, like physically I'm okay, I'm a working port, but you know what? There's no electrical signals. There's nothing at layer 2, no communication. It's just because I don't have a cable attached. So now we come to this big question. A default gateway. Most of the time, a router will not have a default gateway because it's a router. It is a default gateway. You know, people right here are saying, hey, I go to you to get elsewhere. You're my default gateway. So the reason I left this on there from the switch side is you can make the router have a default gateway by going back out to caps lock to global config and doing IP default gateway. Just like you did on a switch, and then you type in the IP address of where it goes to get to the internet. But that's not normally what we do for a router. It's a router. It doesn't need a default gateway. Instead, what you'll start doing is static routes. Now I'm gonna throw one at you. Not really expound too much on it, but let's just imagine that we had an internet connection here, and this is fast Ethernet 0/1. You know, it's our cable modem or DSL or whatever we're bringing in right here. If we have that kind of situation, I can say I want to set a default route. It's not a default gateway because it's a router. A default route. It's actually a type of static route that says send everything you don't know about to the internet. It's almost like a default gateway. So the way I could do that is, first off, I would go into interface fast Ethernet 0/1. Maybe that's connected to my internet service router. Now maybe I am using this at home. Maybe I have, whatever cable modem provider. They don't even give me a static IP address. Well, that's okay. Cisco allows you to type in IP address and DHCP, to where I can have this router get an IP address on fast Ethernet 0/1 from a DHCP server, from my internet service router. And trust me, I'm going to put a whole big picture together of this when we get deeper into the series. But then I would do a no shutdown, bring that interface up. It would grab its IP address, whatever it is. And then I would do an IP route. Now, remember, I'm not really getting into static routing here. I'm just giving you the command just so you can see it, kind of cycle it through your mind, but we will cover it fully. So we're telling the router, I want a route. The router goes, yes. Where are you going? Like what's your destination that you're trying to reach? And we could type in I want to reach everything starting with the number 10, or I want to reach some other 192.168.5 network. What destination are you trying to go to? Well, if I want to say, you know what, I want to route to anything. Essentially, if there's something out there, I want to send it this direction. That's called a default route. That means all zeros. And it says, okay, what's the subnet mask of that? Now, if we were doing a real static route, we would, 255.2. Well, I'm doing a default route which says send everything out this direction. So it's actually all zeros for the IP address, all zero for the subnet mask. And I'll say, in this case, and again, more to unpack later, send it out fast Ethernet 0/1. So what that tells the router is you have an IP address here, and if somebody calls you, if somebody tries to send information to you that's going to the internet, and you won't know exactly where to send it, but just go ahead and throw it out that interface, fast Ethernet 0/1, and send it off to the service provider. Okay, I'm done saying it. More on that later, right? So, last couple things. Shutdown. We have already seen that. No shutdown and shutdown. Banner. We same command, banner, MOTD, message of the day, and we would say caret. I kind of change my character each one we go through, and I don't know why I do this asterisk thing. I just do, and we'll say asterisk. This is a secure Cisco router. And then we will end it with caret. And so I've now got my logon banner in there. Last thing is saving my configuration. Copy, run, start. Now I know when you first saw, wow, we're going to squeeze in what is routing and the base configuration of the router, you're kind of like, that's going to be a long explanation. Well, not really, because everything that we've seen here, almost everything we've seen before, it's the same configuration of a switch, just now applied to a router. And honestly, the configuration is almost secondary to me. I look at that, I'm like, okay, you guys knew that part already, and we will get far more oriented with static routes and everything else that we started throwing in there later on. The big thing that I wanted you to grab, and I want you to walk away with from this nugget, is what is routing. Like that first bullet is everything to me because that's going to be what we grow on. And as we go through the rest of the series, if that piece doesn't quite click, all the other stuff will become like, yeah, but it just won't ever feel good and warm and fuzzy to you. So if you're not 100% on what is router, I encourage you, go back. Just run through the first 10 or so minutes of the nugget and review that. But we did see that. We saw the look and feel of Cisco routers. They look across the board. If you're really curious, hit the Cisco website and just click on their router product lines, and you'll be able to see all kinds of different looks, sizes, feels, prices, modules that you can put inside of them that do different things. And then finally, we looked at the basic router configuration. I hope this has been informative for you, and I'd like to thank you for viewing.